Let f of x equal 2x squared minus 6x plus 4, and g of x equal 4 cosine 1 over 4 pi x. Let R be the region bounded by the graphs of f and g, as shown in the figure above. Find the area of R.
Okay, for the area of the R, let's go ahead and denote which one is which. So this one right here, is that the cosine graph or the quadratic? That's a cosine, so I'm going to go to underline that piece. And the quadratic is going to be the one underneath it. So it says to find the area. So to find the area on this one, we're going to do top minus the bottom. Draw your rectangle if you want. So we have the area is equal to, and let's leave it in terms of x. So we're going to start from 0 to 2. And it's going to be top, which is 4 cosine of 1/4 pi x minus the bottom. And when you're subtracting the bottom piece, don't forget the parentheses. Then we have dx. Second piece is easy to anti-derive, no problem. The first one, we have to use substitution. So let's do some work on the top somewhere. Integral of 4 cosine of, and let's write this as pi over 4x dx. And we're going to let u equal what? The inside. So we have u is equal to pi over 4x. So du is equal to pi over 4 dx. And we know we're going to kick out the pi already, the 4 already on our next step. I need to go ahead and move this one as well. So let's multiply by the reciprocal. We have 4 over pi du is equal to dx. So let's go ahead and substitute that in. 4 is going to come out. 4 over pi is also going to be out. Integrate cosine of u du. Okay, when I integrate cosine of u, what does that give me? Cosine of u. Sine. So we have sine of u. And of course, we're going to plug that back in. So we have 16 over pi sine of the pi over 4x. So let's fill that in on the bottom here. We got 16 over pi sine of pi over 4x. For the next piece, if I integrate the next one, that's going to give me 2/3 x cubed. Are we okay with that one? The next one, let's go ahead and take the negative times a negative and put a plus sign. So we have 6 over how many? What is one more of this power? 2. And then antiderivative of any constant is that constant x. And the negative comes from the outside. And the numbers we're going from is 0 to 2. Okay, which value from here are we not even going to bother plugging in?
0.
The 0. It's going to give everything 0 anyways. So let's plug in the 2 and see what we get. So we have 16 over pi. When I plug in the 2 in here, that's going to give me sine of pi over 2. What was sine of pi over 2? What is the opposite movement on the quadrantal at the top? Just 1. So we have times 1. Minus, let's plug the 2 in and compute while we can. 2 cubed is 8. 8 times 2 is 16. So are we okay with 16 over 3 here? Yeah? 2 squared is 4. 4 times 6 is how many? 24. And then if I plug in the 2 in here, that's minus 8. So let's simplify. Leave the one that's in terms of pi as it is. What fractional value should the or the rest of them give me? Minus something. Should we do common denominator together? Okay. So looking at this, what's going to be our common denominator? Thank you, 6. So I'm going to write out something over 6 plus something over 6. And then, oh, that's a negative too. Minus something over 6. So what's going to go on the top of the first fraction?
32.
Thank you, 32. Second fraction? 72.
Yep.
Third one?
48.
48, okay. So now that we have a common denominator, let's go ahead and combine the top. Negative 32 plus 72, isn't that 48? Not 48, 40. And then minus 48 is going to give us negative 8 over 6. So we get negative 4 over 6. Oh, 3. All right, for part B, Haley, let's read.
Write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4.
So let's do a quick sketch on the side of the original graph. So my original graph is behaving something like this. And that's going to reflect over what line it says. Y equals what? 4. So if I reflect this or rotate around, I'm going to get another leaf right here. Are we okay with that? So when I'm rotating this, am I getting one circle or two circles? 2. So let's go ahead and exaggerate that. For this one, our points are going to come from the original graph, so it's going to be the bottom radius. So in the middle, it's going to be y equals 4. My second one is going to be the cosine graph, so we have 4 cosine of 1/4 pi x. And then the bottom is from our quadratic function, 2x squared minus 6x plus 4. So let's recall the formula with 2 circles. It was pi, and it was big R squared minus little r squared. And it says do not evaluate, so let's just write out what I need. Kick out the pi. We are integrating from 0 to 2. For the big R, it's going to be from top to bottom. My top is y equals 4. The bottom is a quadratic. So I need 4 minus the quadratic. I see some of you guys not writing. Please do. All squared. Minus. For the bottom one, or the small one, it's going to be this piece right here. So that's going to be top minus the bottom again. 4 minus the cosine. Cosine of 1/4 pi x squared. And of course we need our dx. Okay, questions on that one? Good? Okay, the last part. Luke, let's read.
The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Right, but do not evaluate an integral expression that gives the volume of the solid.
So for the square, all I need is what is one side and square it, because it's side times side. So let's take our volume. We're still integrating from 0 to 2. My side consists of top minus the bottom. Did we already do that on part A? Top minus the bottom? Yes? Okay. And the bottom is our quadratic. And it is all squared dx.